Yeah, great. Thank you. I'm happy to be here. Greetings from Boston. Wish I could be there in person. As you see, I'm there in spirit. Maybe next year I'll manage to actually make it over. I'll share my screen to get started. Give me
Super.
1 second to pull up my slides.
I'm impressed by the decoration, by the way. On point.
Thank you. Put some real thought into it today. So, as mentioned, I'm Andrew Therriault. I am a data science educator, consultant. I think, most notably for the topic we're going to get into today, I used to be the chief data officer of the city of Boston. For about 2 years, I ran the city's analytics team and, was involved in a lot of open data projects, not only with Boston, but with collaborations with other cities all around the world. I also have spent quite a few years working in the political sector. I was at the Democratic National Committee, which is in the US, the Democratic Party headquarters. I'm also the co-organizer of the PyData Boston chapter. So, this group is really near and dear to me. So today, what I want to talk about is the intersection of civic data science and open data. We'll get into a bit in a moment about what that means. But I want to talk about those in particular because, as Nicholas mentioned, there's often a challenge of finding projects in the data science and open source community that really make great use of open data and are long lasting and have a really substantial impact. As I'll talk about, we see a lot of work being done with open data and using open source tools, but the number of those that actually make it all the way to having a major real world impact is actually pretty small. And I think I've got a few ideas why, and I want to share them with you today. So we're going to talk about what those challenges are. And I want to provide a sense for everybody watching of, what it means to work with this kind of data, how to design projects that are effective and are successful at reaching their goals, how to build partnerships with, governments and nonprofits and others that you need to really have that kind of impact, and how to make the projects pay off over the long term, how to think sustainably about, what the model beyond just the initial release looks like in order to make sure that you actually have a substantial impact. So just to get started, I want to talk about some sort of basics of what we're discussing today. So this is the definition that I use for civic data science. It's the application of data science methods to support the work of governments, nonprofits, advocacy groups, political campaigns, and other organizations which exist to deliver positive social impact. And there are two things I like to focus on here. One is the idea of data science methods. I define that really broadly. So, that's everything from your basics of data management and analysis to all the way to predictive modeling, AI, machine learning, all of the fancy tools that get a lot of press. I think the entire spectrum really matters. I define data science pretty broadly to just say it's the scientific use of data to accomplish a real world goal. The other part that I think is important here is the last bit about these organizations existing to deliver positive social impacts. I think it's an important distinction to make when you compare it to the commercial sector where, the goal of an organization is to make money, and maybe they have a positive social impact as well, but ultimately the motivations matter. And the reason I think civic data science is important, number one, is that I think these organizations are really important because that is their main goal, that it's not just a byproduct of trying to make money, that the entire focus of these organizations is to promote civic good. And I should note too, when I talk about social good or civic good, that is a subjective definition. What I consider good is not necessarily the same thing that one of you might, but overall the idea is simply that you're doing things for a reason other than to make money. And I think this is something where the open source community is really tied into. I mean, when you're developing open source software, you're doing it to enable others to make use of it above and beyond what you yourself might actually make of it. And that's something that's done for a social good. It's not just being done for your own commercial gain. That's the opposite of open source software. But I think what's really important about civic data science particularly is that there's a huge potential for impact. And the reason for that is simply that these kinds of organizations tend to be constrained in resources. And that's really the circumstance where data science is most vital and has the biggest impact. Because through making things more effective and efficient, you're able to really help overcome some of those resource challenges that those organizations face. But the other thing too I want to point out is it's not just about doing this sort of moral good in the world. Working on these kind of projects is actually really exciting. They're often fun to work on. The people you work with are really great. And there's a lot of opportunities to do creative and innovative things. And, all in all, if you have a chance to do it, I'd highly recommend it. So open data. Well, what is open data? There are many definitions you could point to. I think the key factors that you should think about when you're thinking about open data is that it's data that's published in a public forum that's available to everybody and can be used for any purpose, that there's no restrictions on what you can and can't use a given data set for. And ideally, it's published in some kind of machine readable, easy to use format. The point there is once somebody publishes it, it's out there for anybody to use for any purpose. And when we talk about it today, I'm mainly going to be focusing on government published data. That's what I have a lot of experience with, and that's what most people think of when they think of open data, but there are other sources as well that also fall within this category. So when we're talking about government data, there are a few different areas that this comes into. One is government research. So maybe the most classic open data set that honestly I didn't even really think of as open data until I started preparing this talk in the US is the census. The Census Bureau creates these huge data sets of all sorts of demographic characteristics of the population. Likewise, there's a lot of public data sets about economics. There's a lot in the news these days about public health with the COVID-19 crisis. There are other things like weather data sets that you might not even think of as open data, but really that's simply because they're so essential to a lot of what people rely on every day. And then there's data about public services that are provided. It might be police or fire or emergency medical services. It might be things like education or healthcare or housing. All the things that a government does to provide services for a community, those generally create data, and open data programs often publish that data so others can use it for whatever purposes they see fit. There's also internal government operational data. So that'll be things like budgets or expenditures. When I worked for the city of Boston, it was an interesting time because, my salary and everyone else in City Hall, all of our information about that was public record. It was published in the community. When my job was announced, there was an article in the Boston Globe, our local newspaper, that listed, my background, my experience, my title, and how much money I'm going to be making. All that stuff is available. There's also a lot of information about properties. And this is one thing that I think a lot of people don't quite recognize that government is the maintainer of, but everything about property ownership, valuation, transactions, and obviously in some countries, maybe this is different. And I'm mostly speaking to the US here, but from what I've seen in a lot of places, it's similar, that this is all maintained by the government and made available through either open data programs explicitly or through different government programs that then pass it on to other organizations. And then finally, a key part of open data is geospatial data. Everything you see on a map that you would think of as street names, addresses, all of that is maintained by some government agency that's responsible for coordinating that kind of information. And so, at the end of the day, you might pull something up on Google Maps or OpenStreetMap or somewhere like that. But, generally that originated with some government planning office that decided, this street has this name from this place to this place. And so all of those kinds of things, as well as all the characteristics of things around a city, those are available in geospatial data sets. So just to give a really brief overview of what an open data program looks like, this is Analyze Boston. It's the open data portal for the city of Boston. It's actually the city's second open data portal. We released it about a year into my time there. And, we really overhauled the entire program. If you dive into this site, you'll find currently, as of at least last Monday, they've got about 160 data sets published. And many of these update every day. As you can see here, there's a whole number of these that they update on a daily basis with the latest data. They sync directly with internal systems. Just to pull up one of these data sets about electricity usage at the central library in the city, this is something that's recorded by an internal electricity meter that it's stored on city computers. And then every 4 hours, there's a script run by my old team that grabs that data from whatever server it lives on and pushes it up to our open data portal. So if you wanted to build some kind of real-time monitor yourself, you'd be able to do that as a developer, anywhere in the world. So what this looks like in practice is, this is really raw data. In this case, it's simply a date time and the amount of kilowatts being drawn at that particular point in time by the building. And you have the ability to view it online. You can download a CSV or some other format, or you can query an API if you want to pull the data to build it into your own application. So just to give a few brief examples of what this often looks like in practice when people use this data. So this is a project that's near and dear to my heart. It actually started out as something that originated from my team at City Hall. It was an idea that we had based on our work on our city's Vision Zero program, which was all about reducing crash fatalities and injuries to zero on our streets. And we decided that this was something that was broader than Boston, and we wanted to build this on a sort of open source model. So we actually partnered with a sadly now more or less defunct volunteer organization called Data for Democracy. And this became an open source project. Essentially what it does is it takes things like crash histories around the city, combines it with features of the various streets, and develops a predictive model to say what is the risk on any given street segment. And this can be used by traffic planning departments to figure out what kind of interventions you can take to minimize those risks. It's currently available for 6 different cities, and the team's working to build more. You can find more information about that at insightlane.org if you're interested. Another project that came out of Chicago was about using open data on E. coli measurements at the city's beaches to build a model to predict where there is likely to be high levels of hazard at these beaches. And so this was a collaboration with a community developer group where they basically built an open source model to improve forecasts for the beaches where they're not able to get a recent measurement to figure out, well, where should they be paying attention to? They didn't have the resources to measure at every beach every day. So they would take the measurements they did get and use that to predict where they should focus next in order to improve the quality or improve their knowledge about the water quality at all these sites so that they could protect the public's health. Another project, sadly, the illustration isn't that helpful right now because there's no snow on the ground. But in Syracuse, they built an app, an open source tool to take real-time information about the snow plowing throughout the city and display that on a website so that citizens could see where where the snow plows were when their street was going to get plowed. That saved a lot of time and energy for them to reach out to City Hall directly to try to ask those questions. This is something that a lot of commercial providers would make available, but at a pretty substantial cost, and they were able to do it with open source software and make it freely available. And this is a project from a non-government group. It's an advocacy group in San Diego where they took government data from the census and from state nutrition programs and mapped where childhood poverty was concentrated throughout San Diego County in California. And they use that to provide insight for anyone who wants to look at this to see, where is poverty concentrated and where do they need to really put some work in. And then finally, an example that I mentioned kind of earlier that, anytime you pull up a weather app, if you're pulling out your phone, you're getting information from Google or Apple or whatever, those organizations generally aren't collecting weather data and producing their own forecasts. They're taking government forecasts from places like the National Weather Service in the US or similar organizations in Europe and elsewhere. And so that kind of information, it's not something you typically think of as open data, but it's really a vital commodity. But so it was actually a challenge to come up with even just 5 examples of this because, for the thousands and thousands of projects that I see produced every year, very few of them actually get to that point where you have something that's worth pointing out in a conference presentation. And there's a few reasons why for that. And, these are problems that I think any data scientist will see is not unique to civic data science, but is particularly important here because of some of the unique challenges. So problem one that often comes up is just that people sometimes have a poor understanding of the data or the subject matter or the stakeholders or users involved. Data scientists are notorious for jumping into new fields head first and saying, I know all this stuff about data, therefore I can solve your field's problems without really understanding the context. And likewise, the second problem that happens is sometimes things get built without what's called a theory of change. That is some mechanism by which whatever's getting built will translate into some real world impact. Oftentimes people think, well, if I do an analysis or I build a map or an app or a model or whatever, change will just happen afterwards without really thinking through what that mechanism looks like. And as part of that, the third problem comes up, which is that there's often a failure to connect with those potential end users who could actually build something or do something with whatever you're producing. So, for example, in the case of that crash prediction model, the end users would be these transportation departments in cities or states or national governments who might actually be in a place to make changes that would, say, solve problems on high-risk street segments. If you're never getting your deliverables to those people, it's hard to see what that mechanism is for actually having the impact you're looking for. Also, with some of these projects, you have an over-reliance on single individuals or small groups who are generally volunteers and not getting paid to do this, and so their availability is limited. And even if they're really enthusiastic and committed at first, it's hard to sustain that over time. There's also, along the same lines, often a lack of quality control or refinement, where a lot of these projects make it to the MVP stage, to the sort of minimum viable product, but they don't actually get refined to the level that they would in some kind of commercial application. And so it'll be almost there, but not quite ready for actual use in the real world. And then finally, after something is built, oftentimes these projects, you get to that MVP stage, but nobody thinks about what comes next. How do you deploy it? How do you support it and maintain it going forward? And that means a lot of these projects, they get released, they get some press, and then they just kind of go away. And being able to deal with all these problems is really what differentiates good projects from those that we see all the time coming out of class projects or hackathons that never really go anywhere after the initial development. So, one of the things I do when I teach my students data science is to really emphasize the importance of project design. And what I mean by design is the part of a project you do before you ever dive into data that, I'd like to think of it, it's like a pen and paper exercise. It's not something you're doing with code. It's really the part where you think through your project ahead of time. And what you're trying to accomplish here is to think about, what is the purpose of your project? What is the scope of it? What are the things you want to do? What are the things that are outside of that scope? And what's the final output? You also think about things like who are the stakeholders and users, and you think about the requirements for success and what risks could come up. This is often used as an opportunity to get feedback from whether it's your potential users or some partners you're working with, or even just other data scientists before development starts, so you don't spend a lot of time doing something that has a foreseeable problem. And it also, when you're working with a team, gives you a shared vision and roadmap that you can then use to drive the rest of the development. And like I said, this is important to all kinds of data science projects, but it's particularly key for these civic data science projects because oftentimes if they start going off in the wrong direction, they'll lose steam and never get finished. And a lot of these issues that come up are often preventable. So I put together 10 questions here that are worth asking when you're coming up with a project design. So first one is simply, what is the overall goal you're working towards? And what I mean is, what's the real world problem you're trying to solve? For example, in the traffic modeling or the crash modeling application, the real world goal is to reduce the risk of crashes on city streets. And then you ask, who are the stakeholders, partners, end users? Sometimes those groups will overlap, sometimes they'll be distinct, but you need to identify them to be able to really build to their needs. And then ask, for these users, what do they want to know, and how would that actually help them accomplish that goal that you set out in the first question? It helps to remember that data science provides value by providing information, that it helps others do their jobs better. So this is the point where you really define what is it that would be helpful for them to know. And then number 4, to get there, what inputs do you need? And how do you get them? So what are your original data sources? What are the things that are available, but don't quite answer the question or provide the information that the users need in its current form? So then 5, what follows is, how do you transform that data to get there? And what does the end result tell you? Sometimes it'll be exactly what you want in number 3. Sometimes it will be something slightly different, or there'll be caveats. And it's important to really understand what it is you're producing. So then number 6, what kind of resources do you need, whether it's time, technical infrastructure, support from other people, or whatever? What do you need to complete the project? This is a point where you kind of do a sanity check and say, does this make sense? Do I have everything I need? And what you might find here is, well, this is a good project idea. I could do it, but I need these resources that aren't available. And at that point, maybe you say, well, I'm going to go look for those. And if I can't find them, I'm not going to start and waste my time on something that's not going to eventually succeed. So then 7, this is also the time to think about what the risks are that could make your project fail. It might be, one of these requirements isn't met. It might be that, some potentially unforeseen circumstance comes up, like, a data source that you were counting on suddenly goes away. In some cases, that might, lead you to try to mitigate those risks. In other cases, maybe there's nothing you can do, but at least you have a good understanding of, well, what's the likelihood of this project succeeding or failing? And does that justify the resources needed to complete it? Number 8, how do you validate the quality of what you're producing? This is a really important thing, whether it's a model, an analysis, an application, or anything else. Because not only do you want to make sure what you're delivering is high quality, you want to know how you can use that validation to build trust among these potential end users, many of whom probably aren't that technical and might not instinctively trust what you built the way you would, because you know how it works and they don't. Then number 9, how are you going to provide those results to the end users? Are you going to build an application? Will you be giving reports? What does this look like? And what needs to come with it in terms of training and documentation and so forth? And then finally, number 10, what happens after you've delivered? Because a project, is going to continue on in the long term, and what does it take to make sure it delivers value over time? So just 2 specific points I want to delve into before starting to wrap up. One thing is about the importance of partnerships. So it's critically important to make sure that you find people who know about whatever subject area you're working in, and ideally have some ability to affect change in that. And generally that means people who aren't data scientists. They can help you understand the subject matter, understand your data, figure out what's actually a useful research question to answer. A lot of times, what data scientists think is an interesting finding or a useful tool might not be, for reasons that we can't foresee because we're not on the ground. And then also, these are the people who will put your results into practice. And so if you really want to have an impact, you need them on your side. And finally, in the long term, in an ideal world, it's really helpful to try to get these people to put the results, or to put whatever you build into sort of long-term support on their end, rather than requiring you to keep maintaining it over time. And so when you're working with these partners, I think it helps to think through what their incentives are, what are their limitations. And sometimes you might, have to look around for potential partners where, maybe, for example, I want to build something for Boston, but the partner, say in the transportation department here, maybe they're too busy to help, or they're a little skeptical. Rather than just giving up, that's a time to say, maybe I'll go over to Cambridge across the river and say, they might be more interested, or look at, a smaller city even. And that might be a way to get off the ground, where then if you have success with them, you can come back later to Boston and say, hey, are you interested now that there's something more to show? And then finally, be respectful of their time and expertise. Recognize they may not be data experts, but they're experts in their own field. And, listen to their critiques and feedback and be willing to change your direction based on it. And then thinking through to the long term, just remember your project's not done when you think it's finished. You're going to need to provide support to users, provide ongoing infrastructure. There will be things that come up around changes to data sources and dependencies and so forth. A good project should also be monitored and quality controlled over time. And if something goes wrong, somebody's going to need to fix it. And at the end of its life cycle, somebody's going to need to figure out, what happens when, just incremental changes aren't enough to keep it producing value. And, in the big picture, I think it's worth remembering that a poorly supported project is actually potentially a worse outcome than nothing at all for your partners and end users, where, maybe what they're doing right now isn't ideal. It's not the best possible solution they could have. But at the same time, maybe it's working for them. And if you were to give them some new tool that then breaks later on, that could actually leave them worse off than if they just kept doing what they're doing. And so if at all possible too, the other piece of advice I'd give is it's ideal to have long-term support provided by people who are actually getting paid to maintain it, rather than volunteers, because obviously they have an incentive to make sure that this stays current and accurate over time. So just to wrap up, a few final thoughts I wanted to offer. The first is simply think about the value proposition of data science. And I mentioned before that it's really about providing information to others to do their jobs better. The flip side of that is, stay humble and remember that data scientists aren't generally the people who produce anything themselves. Their job is to help other people do their jobs better. And so that's really why these partnerships really matter. If you're passionate about a specific area, I would really strongly advise you to spend some time learning how it works, not just by diving into the data, but actually going and talking to people, reading books, really starting to understand the subject so you can be an effective contributor. In terms of doing project designs, I proposed a lot of questions you should ask. It doesn't mean you have to know all the answers to get started, but it does help to at least know what you don't know so you can have an idea in mind of how you're going to get there, how you'll answer those questions. And as you go through a project, you should be open to changing direction if you learn new information, or even walking away if it's not working out the way you planned. Your time is valuable, and in some cases, it may help to just put your head down and try to power through obstacles. But in some cases, maybe not. Maybe you learn something that says, "Oh, this original idea I had isn't really what's needed," or the data we have doesn't really tell us what we thought it did. And maybe it's time to think about how to spend your time in a better way on some other project instead. Thinking deliberately about your projects helps you do that. And then finally, if things do go well, you also want to think about how your projects can scale. So, I mentioned the crash modeling project where we wanted to start it for Boston, and then we realized why not do this as a general thing that's available elsewhere. So any city with similar data can plug theirs in and get these kind of outputs. That's really kind of the ethos of the open source community after all. And so if your project goes well, that's a great time to think about how do you generalize that to other use cases. So finally, all right, hopefully I've sold you on the importance of these kind of projects and got you a little excited about it. So how do you get started? Well, there's a lot of different ways to get started. You could start going through open data sites on your own. You could talk to people who run an open data program. I would note that those people tend to be pretty busy and overworked, and they may or may not be available. Don't take it personally if they don't quite have time to hold your hand through it. But you could also get involved with community groups and work with, say, the people who produce this data in the different government agencies or departments or programs. You could also connect with others in your local PyData group or other groups. And sometimes, depending on where you are, there'll be things like hackathons and open data events. I'm not a huge hackathon person because I worry sometimes that, you're doing the fun part of data science, but then just walking away before the hard part comes. But it is a good way to get started. And I think the key, no matter which direction you go, is just remember to think deliberately about what your projects you're building and plan for the long term, think through what it takes for it to be successful, and then, commit to it enough to follow through and, make sure it really pays off on its full potential. So that's all I've got. I don't know if I have time for questions right now, but I will be on Discord afterwards. You can also reach me on Twitter, and I've posted the slides to GitHub. You can see the address here. So if anything you want to go back and look at, please do. Thank you.
Andrew, thank you so much for your talk. And I really hope that this inspires some people to check out these projects, and also given the consideration that they deserve to hopefully go from purely hackathon to something that's sustainable. I would say if you're up for it, considering this is the very last talk, it's no issue if you run over a tiny bit. If you feel like having a look at the Q&A questions that are currently being posted, maybe you feel like answering some of them.
Yeah, so the first one, who comes up with the projects in Boston? So this is a really interesting challenge when I was at City Hall where, when I started, what happened generally was I came in with a team of about 20 people. And the existing process was simply that somebody in another department would go to somebody on my team and say, "Hey, can you do this?" And then they'd say yes or no. And so sometimes that we ran into problems where, two people might be working on the same thing without realizing it. Or, we just took on too many projects because individually they all sounded good. But the problem is that meant we were overcommitted and weren't really delivering on the schedule we wanted to or with the quality we wanted. So what we actually did was put in place this analytics project manager role there, where we had individuals on the team. I think there were 3 in total who were tasked with being the points of contact to work with specific departments. We had one that was working on housing and healthcare and education, another that worked on, transportation and public works and other city services, and a third who worked on performance management and budgeting. And, across those groups, they developed long-term relationships with the partners and then helped them scope out, a portfolio of projects that was more narrow, but was a better fit for actually executing at the level of quality and the timeliness that we wanted. Another question, who designs the projects eventually? So it really depends on the particular project. Sometimes it will be that project manager that I spoke of will take the lead and run through all of this. And generally, they'll be responsible for the general scoping and planning of a project. But in some cases, for example, it might be a purely geospatial project. And we had people on the team who were GIS experts. And in those cases, it may just get handed off to those people who are specialists in that particular area to work directly with the partners to plan out the project without much involvement from the project manager. So it really depended on the project and the specific need. In terms of how to propose a different way of setting up hackathons, actually, a good example might be if you were to go to the Analyze Boston site that I showed earlier. It's the address is data.boston.gov. There's a showcases section there to provide examples of work that was done with Boston's open data. And a lot of the content on there came from a challenge we did when we released the new site back in 2017. What we did is we had a month-long open data challenge program where when we released the site, we essentially gave 5 different areas. We had talked to other departments. We had the fire department, the environment department, and a few others that had ideas for what could be done with the open data they were publishing. And so they put sort of calls for projects out there. And then we basically we set up a competition where we gave teams who in some cases were students, in some cases were community members, or even people at companies who had a little extra time to work on things. And we tasked them with working on one of these 5 areas. And then a month later, we did a full day open data challenge showcase where we basically had all the teams give presentations. We had the community pick winners for various prizes. And overall, that went really well. I wish that was something that had been able to continue. It's just event organizing, as the organizers here know, is a lot of work. And we weren't really set up to keep doing that over time. But what actually was really great about that was by giving teams the opportunity to spend more than just, say, a day working on a project, but build it over time and get feedback, that made for a lot higher quality projects, a lot more polished. It also gave an opportunity to connect with the stakeholders. So, when we had these presentations, we had people from the fire department and the public schools and the environment department and all these others at the events. And so that really provided a way for them to see what the point of publishing this data in the first place could be and really understand the potential of the things that could get built. And some of those things, generally hackathon projects don't turn into, long-term projects directly, but in a lot of cases you do see that they get adopted or adapted, by internal teams and improved on from there. So, we did that. We certainly did that at City Hall quite a bit. And then also at the Syracuse example that I showed earlier, that was initially a hackathon project that then ended up getting brought in, and they had, I believe it was a fellow on their team who was, I think, a summer fellow or something, took this and worked on it for several months and built it into a real product. So that's often a great way to kind of make that transition. And like I mentioned, I am a big fan of having these projects eventually owned by people whose job it is to maintain them over time. And so sometimes that's actually a really good model for collaboration.
Awesome. Thank you so much. That makes a lot of sense.